look in your binder right now. What should be turned into me is everything up to 722, because that's due today. Like, or was due yesterday, actually, I mean. So, if you have yet to turn in one of the assignments up through 722, you owe me. And there are people in this room that look like they are sitting there thinking, oh, like, hunky-dory, everything's cool, and it's not. You owe me work. Then it's graded and handed back, and Anna, you have a check mark over here. I have grade. Reminder, I keep an old-fashioned grade book that I can give you papers back before they go into math. Because I'm an old man at my heart. I'm also like an 11. I'm also like an 11-year-old if you look at my sense of humor. But my soul is an old man. Like, I would go home and put on my vinyl record and turn off my cell phone and actually like throw it in the garbage disposal if I could. Like, I would love to just like go back to simple times. But we're here, and I'm recording my lesson to upload to YouTube and using 8 billion layers of technology. So hey, we're here. 723. Max, sorry, you had a hand up.
762. I had a bit of problems with that. Yeah, I don't know how to answer.
So on 62, and this is part of what we're... I love when I ask a question, then immediately start talking with the person who's answering my question. People love that. In 62, I believe, I got to flip to it, but I believe this is stuff that we're still practicing more of today. So remember with CPM homework, sometimes it's meant to make you feel like a little like, am I certain about this or not? So that you talk with people. Like, I don't know, your classmates, or I don't know, your teacher. So if we forgot exactly how to calculate a slope, we can look this up, either in our CPM book, on Google, whatever. But what we talked about the other day, can you remember the fancy word for the nice points? When we hit the crosshairs, what did we call those? It started with an L, Lily? Yeah, lattice points. So what we want to look for here are nice lattice points. And guys, one that's... Amelia, you all right?
Yeah.
Go get a drink if you need.
Dying.
I know.
Yeah.
Okay. One lattice point. Hey, bring it back together. Bring it back together. I know Brenda's a ghost, but we got to move on. One lattice point is the origin. Right? So if our line passes through the origin, we can use 0, 0 as one of our lattice points. So then we're looking for the nicest, like, I know it's sometimes hard to tell when it's printed, and it's nicer if we can zoom in. But what's the nicest, like, I keep asking this wrong. Where does our line cross a very nice intersection and look perfect? Anna? An x of 5. And the y of 3, and then we can verify that by finding another lattice point that uses the same relationship. So we went 5 and 3. If we go another 5 and another 3, it should hit another lattice point. So guys, your lattice points can confirm each other. But be careful, slope is rise compared to run, making our slope, in this situation, 3 over 5. And we're going to write all of this down again today in class about how we calculate slope, especially if the origin is not one of our lattice points. Because slope has a trap door that a lot of you will try to fall into. For B, I think it's here, which is actually 2.5, 3. So if I try to verify that with another lattice point, this one is much nicer because they're both whole numbers. So then my change in y compared to my change in x, 6 over 5.
I knew the answers, I just don't know how to write them.
Slope is best written as a fraction. You can use a decimal, but it's best written as a fraction. And then in C, guys, C has a trapdoor just because the scale. It looks like your slope is 2. It's not, because your scales are different. Tricky, tricky. This really is like a kind of like a trick question. I would not very likely give you a problem like this without warning you, check your scales. But guys, here, 1 is 2 boxes. Here, 1 is 1 box. That means our slope is 2 over 2, which is 1.
I see nothing wrong with a little trickery.
Oh, yeah. As long as they know to watch out for the trap doors, right? Just be aware.
I didn't find out until I was looking at it. It doesn't make sense.
We're stuck in a never-ending
And I kept on looking at it for like a good 10 minutes, and then I found out. Then I found it. Like I didn't know a problem, then I looked at it.
We're just stuck in a dungeon with never-ending trapdoors.
See, one of the reasons that I like to warn you about this stuff is I feel like it saves time for myself. Mr. Hall works his butt off. Like he's leaving right now to go be a basketball coach. And then I help out with extensions. Like he works really, really hard at everything he does. He will throw like more kind of like tricky type problems at you. Because one, you're another grade older and you should be thinking a bit deeper and more critically. But also, he's perfectly happy for you to have to come to him and like because you fell in the trap door. And so am I. But like we're all still kind of getting back used to the swing of school. So I'm trying to be a little nicer to you guys. Know that Mr. Hall will do more of this like kind of tricky type stuff. That's not mean or anything. He's just trying to see who's got their brain turned on.
What team does he coach for?
I think Hilliard? It's like a friend of his asked him, hey, I need another coach for our team. Can you come help out?
Is it high school or middle?
Yeah, it's like a high school basketball. All right, other questions on 723. My apologies. I was trying to say 62. Who, what? Do you mean 63?
Yeah, 63.
623? What are you talking about?
763.
763?
Yeah,
On
on 63.
723?
On 723.
You keep saying 6.
I said 63, like the question.
Okay, so with our masks, when you're saying 63, it sounds like 623, and I keep getting very confused.
No.
Okay, 63, which part of it?
You killed Lily. Both.
There are D amounts of parts.
Wait, what? Easy. I only C and D on this, so just do C.
Oh yeah, I was nice and I cut off A and B. No, they're on the front. Yeah, A and B are just on the front.
Yeah, I thought there's only two parts.
Okay, never mind. Yeah, I did the. Okay, yeah. Just C. Can you do C?
C, I can do C.
I see.
So, there are a few methods to solve this, but one, when we have an equation that starts with fractions, is to bust a move.
What's fraction busting?
Fraction busting.
I forget how to do that.
So, bust a move relates to a song that you guys probably don't know. But, if our denominators are 3 and 4, what could we multiply the entire thing by to destroy them? 12. So we multiply the entire equation, which really means we're multiplying by 12 on both sides. How this works, as a reminder for your fraction buster technique, is 12x over 3 plus 12 equals 12x over 4 minus, it's hard to turn a plus sign into a minus, minus 12. This is 4x. This is 3x. I'm going to go ahead and add 12 to both sides because I don't like negative numbers. Actually, I don't know. Sure, because I already said it, but then I'm going to be stuck with a negative number because this is going to be 24 right? And I could have waited to do plus 12 now. But now what I've kind of stuck myself with is my variable is going to become negative if I keep my 24 over here. So now I get negative x equals 24. And if negative x equals 24, that means positive x must be negative 24. Colin. We could have. But I had already said it out loud, so I decided to commit. D, with decimals, there is still a fraction buster. Although we should probably call it like decimal destroyer. What decimal place is the furthest decimal place here? They're all just tenths. Ah. So, here's the tricky part. All of this is one term. So if I multiply the entire problem by 10, I get 9x minus 21 plus 9 equals 2. And these don't get multiplied. Because this, imagine it being, like, forget about 5 minus x. Let's call this z. Imagine that that's 2z. And you get told to do times 10. I wouldn't do 20 10z. Like, wait. If I multiply this by 10, well, yeah, but if I multiply this by 10, it has multiplied the whole thing by 10. Because this times 10 carries through. So this is tricky because people will try to treat this like when they're separated through additions and subtractions, and we do not. If you want to justify or defend why this works this way, do the distribution first, and then solve it, and then solve it the other way. It's got to solve out the same both ways, right? So now this becomes 10 minus 2x. And we can solve out. Like, I obviously haven't done anything with the left side yet, but I think we can algebra from there. Brenda.
On A, I got the answer right, but when I went to check my work, because it says check your answer, I got it wrong, and I don't know what I did.
Then you made a math mistake on plugging your answer back in. Because if your answer for A agrees with 5.5, then some part of you checking your work, you did the math wrong.
I don't know how you do B.
Jake, do you seriously want me to answer that, or do you just need like 5 seconds to look at it?
Yeah, I seriously want.
Okay, well then you're gonna help me do it. So on B, like boy, right? Like badger, boy, B. Just making sure you said B, not C or D.
Yeah.
The variable's over here and nowhere else. So the Hudson advice here would be just go ahead and leave the left side to be your variable side. How do I get rid of a minus 6, Jake? We add 6 to both sides. So then I'm going to get 1/3 x equals 14. Jake, how do I turn 1/3 of something into all of something? Times 3. Hey, look, Jake, you knew how to solve this problem, even though you said you didn't. Jake, you're a liar.
Wow, I like lying to you. It's so fun.
Amelia.
Well, I have a question, but I also want to tell you that your wedding speech thing also helped me on my math test.
Not nice.
Yeah.
Oh, because complementary angles? Because we haven't done our real geometry unit yet.
Complementary, like there was things like adding up to 90, but then there was also supplementary and like that stuff and like the 180. It's like you helped me remember.
Aw, thanks.
And
I'm glad.
And it was fun to hear.
It was fun to write.
For the wait. Now I'm confused on what I was gonna ask.
Colin?
Can you just finish the sentences?
52038.
Now I remember my question.
Amelia.
Are we allowed to draw the lines for 65 on the graph that they had, or do we have to make a whole new one?
So this again is one of the problems where I went the extra mile to put this stuff on your paper. Of course you can do it on the graph that I put on your paper. So if you were doing this from your book, this would be in your book, and you wouldn't draw in your book. But since I turned this into a worksheet, you can do it on here. Or do it on your own. But guys, remember, if you only need a little bit of graph paper, I've got the baby graph papers up there that actually Anna has said that she likes better because ink doesn't go through it. Like, it's kind of thicker paper. So like if you're using a pen, ink doesn't go through it. If you are any of the people that owe me homework and you are just sitting and chilling right now, instead of trying to do something, you're making a poor choice. Aiden. On 61. So we're going to talk about this stuff today in class, so I feel like we should probably move on. Guys, and this is what I mean with like me trying to save myself time and save you time. I know what mistake you're probably going to make, and I made this, right? I counted boxes, and I know that to scale all of this or to show all of this, you're likely going to need to scale your axis because you need to go from a -9 to a positive 13.5. So you better believe that if I took the time to make a special note right here, I'm probably checking, did you actually do this problem? Because it takes a little effort. Like on, I forget if it was 721 or 722, did you actually draw the box and whisker? And if you didn't, you got to check minus. Yeah, Anna.
Should we, like you were just saying like you're going to talk about it in class, does that mean we should turn it in?
You don't have to yet. 723 is not due. Yeah, it is. I guess it's due today. I mean, hang on to it for now. You'll know what I mean in just a second. Like, so all that we mean there, because I feel like I'm being elusive here, is if you talk about, so this is the first problem for today's lesson. So don't worry about, I don't know what Gus is doing, but don't worry about turning that in right now. I'll try to give you some time at the end of class, because I probably need to set an alarm anyways, because we're on a different schedule. Go ahead and write down slope on your paper. Today is 7 something. 724. Graph paper. Like, graph paper for the lesson.
We're gonna write what? Wait, will this be like with the homework or is this like notes thing?
This is like notes that you could potentially use on a mastery sort of thing. So I would try to make these look kind of nice. So we have been dealing with like level 1. Last little swig of coffee. Our level 1 type of slope problems. Now it's time to step it up. So when we have seen a line with a slope of 2/5, what we've mainly seen, like most of what we've done, involves nobody.
What? What are you asking? Points?
There's a mistake in my boot.
Yes! You forgot to put the other one down!
Well, no, not just this, but
Oh, I know. It looks wrong. There's no scale. Because 2-5 doesn't...
Colin, thank you for raising your hand.
Oh.
It's because when you're doing it, it's supposed to put it y over x, so it's actually 5/2.
This is one of the trapdoors about slope. 2/5 does not mean the point was at 2,5. It would actually have been at 5, 2, not 2, 5, because our y would have been 2 and our x would have been 5.
Is this on the homework?
No, we're having class right now. Like, I'm teaching you things. At least I hope. Does that make sense? That we're just like writing on graph paper? So then, if my line kept going, and if it was straight, because I'm a little wobbly up here, and I went twice as far, the next point that I could write down nicely would be 10-4. Good, buddy. 10-4 is an expression that means like I heard you like loud and clear, like Roger that. So I could say that the slope of this line, which we often use the m for measure of slope, is 2/5. Or I could say 4/10.
Or you could say 6/15, or you could say 8/20.
You could say a lot of things, right?
The infinite amount.
We could say it's 2 billion over 5 billion. Right? Now that would be silly. And that's why we literally start to use M's and B's and stuff instead of writing all the zeros. So most slopes we talk about are in reduced form. Talk with your team and figure out which of these slopes is steeper. 2/5 or 5/2.
I have 5. Wait, I don't have a 2. I'm all by myself.
No, it's not 5 2.
I know Lily was just like, no, sit back, and then she just stopped herself. Like, oh wait, I'm telling somebody what to do. I should probably stop myself. Then you probably should. If you need to, you probably should. And I would go there first. What? Go to the bathroom and then use the bathroom. What? He said I need to use the bathroom. I'm like, well, I mean, okay, go there. I should probably shuffle up. We haven't shuffled in a while.
He's wrong.
I mean, maybe you should become a teacher because that's our entire job is telling kids when they're wrong. Jordan?
Is X the top one or the bottom one?
Yes. That is the question, isn't it? If I asked you to compare a slope of 2 to a slope of 10, which do you think, Walter, would you say is the steeper line, 2 or 10? If I told you a slope of 2 versus a slope of 10. Okay, let's just do vote. Who would vote for 2?
I mean, I kind of like 2.
Who would vote for 10?
Oh, I'm over both.
10's a bigger number, right? So, slope has a lot of synonyms. I'm doing the quietly stare thing to try to get people back with me. Slope can be called gradient, inclination, pitch. But a lot of times how we talk about this is the degrees of the angle, right? Slope, we almost always are talking about some kind of angle. Not an angel. If you spell it wrong, if you spell it EL, it's angel. Angle is LE. And if I ask you to compare an angle of 10 degrees versus an angle of 2 degrees, which one would open up more? The 10 degrees. Slope works like most of our number systems, that the bigger number is more. Meaning if I compare my slopes of 2/5, which if I make it a decimal would be 0.4, versus 5/2, which if I make it a decimal would be 2.5, which one would be steeper?
2.5.
The 2.5, because 5/2 says go up 5, go over 2. So slope of 5/2 is steeper.
I thought it was the opposite.
I know. This is why we're reviewing this. So slope, what I need on your paper.
Yeah, look, he just drew it.
Slope, what I need on your paper. Now that Max is back, is vertical over horizontal.
Can you go back up to the graph for a second?
Yeah, this is the problem with me writing so big is then I have to keep scrolling so far.
Vertical, which one's horizontal?
We'll get there. I got a bunch more ways to define this. But instead of saying slope, hey guys, this I know that you're all very smart, but regretfully I am the smartest person in the room, at least when it comes to this. I'm sure some of you are smarter than me, depending on the topic. Slope. Mathematicians are lazy. Mathematicians are efficient. So we start to abbreviate things. M is when we talk about slope. Guys, we almost never use M as a variable because we use it for slope. So we pretty much avoid it. M, our slope, is the change in Y. I don't know what the heck I'm trying to do. All right, so here's the thing. You might need to jot this note somewhere. A triangle is used to represent change in.
What?
So it's the change in Y over the change in X,
So
which we
basically,
can
isn't that delta?
calculate.
Like delta?
Yes.
Delta Y, delta X?
Which we calculate by doing Y2 minus Y1. X2 minus X1. Now this is less difficult with the lines that we've been using. And guys, those of you choosing not to take notes, I see you, I know what you're choosing. I think it's a bad decision, but when you get a check minus on your homework, I will just put a see me on it, and then we'll get to talk. This is much easier when these are zeros. Because if I take away 0 and take away 0, nothing happens. So most of what we've been doing that involved this 0, 0 point, we didn't have to think that hard. We just drew a triangle and we're like, yay, triangle. But now, we're going to be working with 2 points that we call x1, y1, and there's these are ones.
What do the ones and twos represent?
We're getting there.
Okay. Thank you. Oh, I thought it was multiplication, so I'm not actually write down those ones then.
What do the 1s and 2s mean? Nothing.
Like the exponents?
Why didn't you write them?
I'll tell you in a second.
Oh, I can guess. Shh. Can I guess?
Sure, because you're probably going to shout it out even if I don't say yes.
Yes. Is it,
Sorry, I'm checking the schedule. How long are we in here? Oh, I still got 10 minutes. Righteous.
it's normal schedule now.
Well, now, these 1s and 2s are what we call, and you don't have to write this down, but it is what they're called. They're nothing like an exponent. Nothing like an exponent. They're called subscripts. And guys, you can do this on Word or Google Docs. You can use subscripts, just make the numbers baby, and they go at the bottom. You'll sometimes see this in writing when it wants you to go look at something down at the bottom of the page where it'll have like a little 5, and then at the bottom of the page there's a 5 and it explains the thing that they're talking about. Or they might say like, oh, in Professor Satoy's writing, blah, 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 and then they talk about the writing on like a separate page. That just tells you, okay, no questions for a second, just let me get this out. That tells you 1 point is x1, y1. The other, sorry, this gets weird because the comma between x and y. The other point is x2, y2. But here's what I mean by they don't matter. Here's what I mean by they don't matter. If I call this point x1, y1, then this point is x2, y2. It doesn't matter which point is which, because negatives will fix each other. If I do the subtraction correctly, it doesn't matter which point is which. I just have to set up the subtraction carefully. Brenda.
So are we just then, like, basically counting,
Oh, you guys keep getting me distracted so much I haven't even gotten to the best thing. The easiest thing to remember.
thin ice?
How much does an elephant weigh?
30 pounds.
Enough to break the ice. Hi, my name is Micah. So slow.
What?
It's just a terrible way to like meet somebody. You walk up and you say, hey, you know how much an elephant weighs? And they're like, what? You're like, enough to break the ice. Hi, my name is Micah. Enough to break the ice.
That is the most awkward thing I have ever said.
I've never heard that one
Does that on
This is the simplest, there you go, simplest. This is the simplest way to talk about slope. It is the rise over the run. And silly math teachers, I don't know, I probably classify myself in there, but sillier than me will tell you you have to rise before you can run. Like you have to get out of bed before you can go anywhere. You have to rise, like get up. But all this means is the change in y over the change in x. So if I give you a graph,
I've always learned that you run before you jump.
if I give you a graph, it doesn't matter if I draw the triangle above the line or below the line. This is where you have to decide what you like better. But we can just do the math. Right now that we've talked about the math that we can do, what's this point? Careful, this is where we have to like double check that we're saying the points correctly. It's 0, 12, right? What's this point? 7? 726?
Man, that sounds pretty early. Pretty late.
What was your change in y?
8.
What was your change in x? So what is your slope?
2.
What?
Try this one. Hold on, no weights yet. No weights. What's that point? 0, 12, we already know. What's this point? Careful. 6, 0. Now, sometimes we can get away without even writing down the math. Careful, though. What's your change in y? Negative 12. Because we went from 12 down to 0. Our change in y is negative 12. What's our change in x? Positive 6, because it went to the right 6. Guys, just always ask yourself, is my line going up or down? That tells you if your slope should be positive or negative. What should this slope be, positive or negative? Negative. So it's negative 2. Now hold up. Are these lines perpendicular? No. And we talked about this yesterday. all because these are opposite slopes does not make them perpendicular. What slope would be perpendicular? Jordan? If we started with positive 2, what slope would be perpendicular to positive 2? Negative. Sorry, I couldn't hear what you said. Negative 1/2. The opposite reciprocal. So perpendicular would be negative 1/2. Because it's, Nope. You can try it. If it's just the reciprocal, it's still going up. Two lines that are like pointed up can't be perpendicular to each other. So remember, a positive slope of 1/2 would look like this, approximately. These are not perpendicular. Find the slope of these 3 lines. Talk with your team if you need to. Send up somebody who can see better than you if you need to. And then I got a 4th line to challenge you with. I know, don't yell at me. I'm making this bigger.
It doesn't like you, Mr. Hudson. Wait, so what are we doing with the thing?
Find the slope of these 3 lines. The slope. Are your axes scaled the same?
Yes.
Yeah, your axes are scaled the same, right? So every box is 1 both directions.
Well, these
How do you do slope if the line is straight?
You don't do 0, 0.
Spencer, for line A, can you tell me the rise of line A? If you're not Spencer, can you tell me the rise? The rise? Well, I guess it depends on where you draw your other lattice point, but if we're using my lattice points, 7, 1, 2, 3, 4, 5, 6, 7.
Please excuse this interruption. I need Douglas Miranda to the office. Douglas, please come to the office. Thank you.
So A is 7/3. For C, Colin, you want to hit me with a slope here?
I haven't gotten to it yet.
I think we can kind of cheat and say that's 10. So anybody? Negative 3/10. In B, Renault, what's my rise between those 2 lattice points? 0. What's my run between those 2 lattice points? 5, 6, 7, 8, 9, whatever, some number. What's 0 divided by 7?
0.
You can have a slope of 0. Max got very mad at me when I gave you a problem on the homework where the car wasn't driving. It's parked. It's not going anywhere. Hold on. Put your hand down for a second. No, you're not listening when your hand is up. Just wait.
Wait, there's more.
Indeed. Hey, give me your eyes. Indeed. I gotta have you guys hear this. If I try to do lattice points and I talk about a rise, whatever number, 5, 6, 7, whatever, then my run would be 0. Can I divide by 0?
No.
This is what we call
Inaccurate.
One person said the right word. Undefined. This is literally, we call it an undefined slope. There's no way to talk about the slope of a vertical object because it's essentially infinity divided by 0. What the heck is infinity divided by 0? Exactly, we can't do it. Max.
This is something you did do wrong. You could write it like that if you're not fun. The way we did it was we made like the parentheses and made a comma and then a parentheses.
So remember when we talked about time and place and like importance and like, did that need to be said before we all need to pack up and leave?
It looks like a fun.
Did that need to be said before we all packed up and leave? Have a wonderful day, guys.
You wanted my eyes?
Ha ha ha. You've done that before, though. If it wasn't you, it was somebody else, which is even creepier, but I swear you've done that before.
I probably have. I just don't remember.
So my hope is that you still got everything from the lesson.